Hi and welcome along to part 2 of this Invicta Model 70 repair. Congratulations if you watched my last video and didn't fall asleep or try and jump off a cliff. That was quite a marathon. But it is all clean and quite nice to work on now. Now I would like to talk about this radio before we start work on it. It is a live chassis set. And what that means is the metalwork here forms the negative HT rail in the circuit. Now in the olden days, well before I was born, but possibly still right into the 1970s, people would use this sort of mains plug, and I've just dropped one on the floor. I'll drop two on the floor. This would be the standard British mains plug. So you could wire it or put it into the wall socket any way around, which means that the chassis here could be live. So manufacturers recognised this and went to great lengths to try and stop people from zapping themselves. So, which is why we have this Paxlin panel here. And they also did things like putting wax in the grub screws in, so you couldn't actually touch any metal. And also things like the earth connection here, the aerial and earth are actually isolated from the chassis because you do not want to earth this chassis. I'll just try and find my plug before I tread on it and stick it in my toes. There we go. These are the other two that I dropped on the floor. So you can see you could stick it in the wall any which way you want. Now, I don't know if you can hear that, there's a Spitfire going over. Probably not. So what we're going to do next before we apply power is look at the various important components. I've already looked at this filter capacitor. It's completely dead. I've tried to reform it at 5 volts on my Heathkit bridge and it didn't like it at all. And then we need to replace the grid coupling capacitor between these two valves here, because if that's leaky it will not do this valve any good at all. Now our US friends might not recognise this component here. That's a dropper resistor. So when the 240 volts come in, it's consumed by the heaters in these 4 valves here, and that doesn't consume all the voltage, so we need a dropper resistor to drop the voltage down so the voltage and current taken by the heaters equals the mains voltage. And as you can see, we've got various tappings here. You might be able to see them. We've got 200, 220 and 240 on here, so you can just move this flying lead here to suit your incoming voltage. Not sure if I explained that too well, but there's plenty of books to read and articles online. So what I'm going to do next is wire up a filter capacitor or smoothing capacitors, 2 of them. That's a double can underneath, and we're going to change the grid coupling capacitor between V3 and V4 before we even start. Then when we're going to come back and apply power. I don't expect it to work brilliantly well, but we can have a look. Right, let's flip the set over and we'll have a look underneath. Now I have a small and very bad circuit for this, which I think I showed you. So you can't really see what, well, you can see what's going on if you really try, but it's not really big. It doesn't exactly tell you what anything does, but using experience you can quickly work your way around a set. So as I mentioned, the aerial and earth here, now the earth is not a power supply earth, it's actually an aerial earth, and back in the day you might have a stake in your garden, a great big copper rod banged into the ground with a separate earth wire. And if you notice, it's isolated using this dirty old capacitor here, and very dry, so hopefully you wouldn't zap yourself. And it's also the little plug thing here, socket here, is on an isolated Paxilin panel there. So on this side, as with most sets made in the UK, we have our RF incoming side, and then it gets detected and demodulated around here, and then gets passed on to the audio section around here, and then we have our power supply section around here. So we've got probably a cathode bypass electrolytic there. We've got 1, 2, 3, 4, 5. So that's on G1 of the CL33. That'll be the grid coupling capacitor. That's the one that people always say to change. This one looks as if it's got very hot and bothered, so that'll need to go. What else we got? We got a good old mix of pre-war, post-war and World War II components here. We've got post-war, we've got a World War II American-made Sprague in here. There's another one there. And this electrolytic, this black covered thing here, I've seen those in pre-war Murphy sets. Just zoom you in on that if I can. Whoa. Just there. So this thing here, under the clip, like a great big black slug. Right, rest of the set, we've got the audio output transformer here, great big lump. That's possibly ex-military by the look of it because it's so huge. We've got two capacitors down here for the tone control circuit. I don't know if I can see the other one. So the tone control circuit would here, and that's probably in the feedback circuit. So that'll provide some sort of brightness to the overall tone. This big black electrolytic is probably a cathode bypass as well. We've got the capacitor across the mains, although it's not exactly across the mains, it's going from one side of the mains to ground, or to earth, or to ground really, chassis ground anyway. We've got a surge limiting resistor here, this big resistor here, and what that's for is to stop the valve going if someone turns the radio off while it's been on and then quickly on again, and that'll stop the valve on hurting the valves. Tone control switching here, volume control there on and on off switch. Now I'm going to check that this is switched so that neutral is off when the it's a switch neutral, which may mean that the chassis could be live if you were back in the day. Yeah, the safest thing to do is to replace that with a double pole switching, but that can cause problems with RF hum. So what I'm going to do next, if I can find it, is, as I mentioned, the big electrolytic up the top there, that is completely dead. That won't even reform at 5 volts on my Heathkit bridge. So I've made up this little set here, and I'm going to attach that there and disconnect the wires from the big smoothing can up the top here, and we're going to rewire this underneath. Then I shall fold these capacitors over so they sit underneath like that. So that's first, and then I'm going to replace that, and then we can have a go at sticking some juice up it and see what happens. I've also repainted this dial section here because all the paint had started to flake off and it was getting everywhere. So I've quickly resprayed that. Right, let's get that electrolytic sorted. Right then, power time. I've replaced the smoothing capacitors and the grid coupling capacitor between V3 and V4. We've got an aerial plugged in. I always forget to plug an aerial in. We've got a lamp limiter on top, and we've got the mains next to my quick block thing. I can't remember what they're called. Safe block. Right, so the set's on off switch is on. I don't know where it's tuned to. Ready? If it's going to go bang, it's going to be the mains filter capacitor that's going to go bang, which I doubt. But let's apply power. Ready? 1, 2, 3. Contact. Right, I've got the lights on, but I don't know if you can see that, but the lamp's quite bright. That's will be on an AC/DC set. Nothing's gone bang yet. The dial lights, 2 dial lights, are both glowing, but there's probably not enough current getting into the set, so nothing's gone bang. There's no smoky joes. We could try and make some. I'm just going to leave it for another minute. And yeah, I can't see anything wrong so far. So let's just apply direct power. I'm going to go full 240 volts. Dial lights have got brighter. Now live chassis sets can take a minute to warm up, and the state of some of these wax capacitors, I apologise if you can't actually see anything, but it's not very exciting looking at the back of a radio. Oh, that's the amp just kicked in. Oh, and we've got radio noises. We've got heterodynes. And we've got some very poorly capacitors, I would imagine. So we've got speech, we've got a station. It sounds very poorly. Let's see if I can turn. Right, so I'm turning the volume up, and at some point the station is just going. So we've got very leaky capacitors. Oh, superb. I don't know what waveband I'm on there, to be honest. I think that might have been medium wave. So it's not very well, is it? This is an EF39, and sometimes if the metallisation isn't connected to ground, they can get a bit funny. I'm not sure that's the case. That might be Radio 5. Let me just check. Yeah, that's Radio 5, BBC Radio 5. So that's the medium wave band. But it sounds rubbish, doesn't it? And the volume control is set to quite a good volume, really. That's more than halfway around. And it should be kicking out 2.5 to 3 watts of audio power, I would have thought. Right, so I'm going to turn it off. So I apologise that wasn't all that exciting, but let me unplug it. But at least we know that it actually works. So I'm going to get on, and I would suggest that, I'll just take you in a little bit, that capacitor there is the AVC capacitor, I would assume. So I bet you things would improve once I replace that. But I think every capacitor in here is going to need to be pulled. Right, so not very exciting, there's not much to see, but thanks for watching.